Let's do the first one. So here we have a cyclic compound, which is gonna be cyclohexane. So that's a cyclohexane. We start numbering based on alphabetic order. When we have a cyclo, so I start from the isopropyl here. That's the isopropyl. If we go back to the branches of alkyl, this is isopropyl. So it's gonna be, we start one here, two, and we should start from the side that we reach the branch sooner. So we start from the side that basically we have a lower alphabetical order. I is lower than M, right? So it's gonna be 1 isopropyl 2 methyl cyclohexane. What about the second one, guys? The second one, what's the longest chain here, guys? This one, right? This is the longest chain, right? So from which side I should start numbering? I should start numbering from the right side because it's more crowded, right? Because if I start, I should start from the left side. Why? Because if I start from the right side, I reach 5 methyls, 2 methyls. But if I start from the left side, I have more crowded in here, right? So I start from the left side is gonna be, and make sure when we write it down, we go alphabetically, is gonna be 5-ethyl, 5-6-6 trimethyl, and we have 10 alkane, 10 carbons in the longest chain. It's gonna be decane, and it's alkane for sure. What about this one, guys? My longest chain here is 5 carbon. Is gonna be, I start from the right side because I reach the double bond sooner from the right side. And I start numbering from the lower carbon, the carbon that gets a lower number in the double bond. It's gonna be 2-pentene. 2, because carbon 2 is the one that reaches the double bond sooner. 2-pentene. What about this one, guys? From either side I start is gonna be carbon 3, and we have 6 carbon. It's gonna be 3-hexane. What about this one, guys? We have here cyclo, and we have a pentyl group attached to it. 1, 2, 3, 4, 5 is 5 carbon. When we have a 5 carbon attached to a cyclic group, we basically we end up with YL. It's going to be pentyl cyclopentane. Let's do this one. What's the longest chain? The longest chain will be the one that has more branches on it. So if you come up with the same number of carbons, you're gonna choose the one that you have more branches on it, because it's easier to name and number it basically. So I start numbering with the one that is the longest chain here. So just a straight line is gonna be 6 carbon, and it has a triple bond in it. I start from the right side to numbering. So it's gonna be 1, 2, 3, 4, 5, and 6. So it's gonna be what? 3-ethyl, And we make sure we go based on alphabetical order when we write it down. So it's gonna be 3-ethyl, 5-methyl, 3-propyl, 1-hexane. And if you remember, if you see somewhere that they don't put the 1 here, they don't write it down, it's completely fine. Why I don't choose this one, guys? Because I have more branches in here. When I choose this one, I have more branches on it of alkyl groups on it. About the second page. So let's do this one. This is cycloalkene, right? So that's the hexagonal. So I know that that's cyclohexene. Then I start from the side that I get lower double bond. So do you think this one or this one I start first? This one is number 1. This one that I'm pointing is the one that is number 1. Why? Because it has the lower branch number on it. So then it's gonna be 1, 2, 3, 4, right? 5 and 6. So then when we write it down, we go with start with the lower alphabetical order. So I is lower alphabetical order than M. So it's gonna be, if you want to write it down, it's gonna be 4 isopropyl. This is isopropyl when you have a alkyl group, and then that's gonna be 1-methyl cyclohexene. You don't need to, guys, emphasize on the 1 here, because in cyclohexene, if we have only 1, you always start with the double bond, right? So you don't need to emphasize on it. What about this one, guys? So we talked about it when we have a halogen. So you start from the side that you have a lower alphabetical order, which is gonna be bromo here, right? It's gonna be 1, 2 is 1 bromo, 1 chloro, 2, 2, 2 trifluoroethane. What about this one, guys? This is when I do remember when I said if you have a long chain more than 4, your benzene group is gonna be the branch basically. So here you have 8 carbon in the long chain, 1, 2, 3, 4, 5, 6, 7, 8, and because your branch is here, is phenyl group, so it's gonna be 1-phenyl octane. What about the last one, guys? Can you help me with that? Is going to be 2,4 chlorotoluene, 2,4 dichlorotoluene, right? Carbon that is attached to CH3 gets number 1, carbon number 1, 2, 3, and 4. And when you name it, you just don't use the root of toluene. We just use the root of benzene. It's gonna be 2,4 dichloro 1-methyl benzene. So this is also the correct name. Let's do the last one here, guys. In the last one, we have 1 chlorine and 1 bromine attached to the ring of benzene. So we start from which side to number? From the lower alphabetical order. So the carbon that is attached to bromine gets number 1, and we go to the side to reach the chlorine sooner. Is going to be 1, 2, 3. is going to be what? 1 bromo, 3 chloro, benzene, right? What's the other way to name this compound, guys? I talked about it. It's gonna be meta bromo chlorobenzene. So make sure when you write the second one, M should be always in the italic format, and make sure to start with B because B is the lower alphabetical order. So it's going to be metaboromochlorobenzene. Priority group table. We call it functional group priority table. What does it mean? As you go to the top of this table, this has more priority other than the other ones, even when we come in naming. Okay, so if you have carboxylic acid in the compound, you always name it with the parent name will be this group. Okay, the parent name of the group will be, so let's have an example. Look at this structure, guys. Here I have a carboxylic acid, right? Or if you remember, if we have a benzene, and this group would be benzoic acid, right? We have also OH with the benzene. I can also name it phenol, right? But I have also NH2 with benzene, which is aniline, right? So which one I pick, do you think? As a parent name to end up naming this compound. I go with the priority group. I see that carboxylic acid, or this group, COOH, this is carboxylic acid, COH, is more prior than OH group, which is hydroxy or OH or alcohol, is prior because it's increasing priority, and also even higher than amine or NH2 or NH2. This is amine group. This is alcohol group. I a little bit talked about it in previous slides. So this is getting more priority. So whenever I want to name this, the parent name will be this one. So I start with this carbon, guys. So do you think I should go this way or this way? For sure this way, because I reach the branches sooner. It's gonna be 1, 2, 3, and 4. It's going to be 4 amino, right? Because when we have a branch, these gonna be the names of them, guys. When we have a branch that is not gonna be a parent name, this gonna be, so whenever you have an amine as a branch, it's gonna be amino. It's gonna be amino. Okay? And when we have an alcohol or OH as a branch, we call it as a hydroxy or prefix. So whenever we want to use it before or as a branch before the parent name, you do remember we talked about it as a child, in the before the parent name, we should use these names. But whenever we want to use it as a parent name or suffix, we use this. For example, we're gonna use it whenever this is a parent that we finally talked about it, that this is gonna be the parent name. We should use it as a oic acid or carboxylic acid. But the other ones will be the prefix or the child. Based on the alphabetical order, when we write it down, we know A is before H, for amino, and we said that the prefixes are whenever we want to use it as a before the parent name, right? So these are the prefixes, and this is the suffix name. So for amino, we're gonna use the prefix of it because it's not gonna be used as a parent name. For amino, 3-hydroxy. So whenever it's not a parent name or we use as a prefix, it's hydroxy. It's gonna be 3-hydroxy. And whenever we want to use the suffix or parent name, we use this one. That's really helpful, guys. It's gonna be benzoic acid. The first picture, you have the COH, CH3, and Br. Do you think which one I should start labeling first? COH. The carbon attached to COH gets number 1 here. Why? Because my carboxylic acid is the most prior group in the this priority table. So whenever you have carboxylic acid or COOH group on the ring, you should make sure that your parent name will be based on the carboxylic acid, which here, because the COH is attached to the benzoic or to the benzene, we call it benzoic acid. So it's gonna get suffix name oic acid. Now we can start with the carbon number 1, and the one that is attached to the COH is gonna get 1. Do you think I should go this way, counterclockwise, or clockwise for numbering? I should go counterclockwise because I reach to the branch sooner, and the branch gets lower numbering. So it's gonna be 1, 2, 3, 4, 5. So the number 2 is methyl. On carbon 2 of the benzene is methyl. On carbon 5 is bromo. When we write it down, these bromo and methyl groups are going to be as branches. So first we're gonna talk about them in the beginning of the naming. So it's going to be 5 bromo, 2 methyl benzoic acid. Pay attention, guys, that when I write the name down, I go with the lower alphabetical order because B is in bromo in alphabetically is lower than the M in methyl group is gonna be 5 bromo, 2 methyl, and it's gonna be based on benzoic acid because it's the most prior functional group in this table. What about the second one, guys? Do you think which one is gonna be the most prior group? Again, you're right, COH here because it's most prior in the periodic or is the most prior group in this table. So we're gonna start put the number 1 on the carbon that is attached to COH, and we go counterclockwise. The carbon that attached to OH gets number 2, and how we name it? The OH, you can see when we want to use it as a prefixes or at the beginning of naming is gonna be hydroxy group. So it's gonna be on carbon 2, we have a hydroxy group, is going to be 2-hydroxy benzoic acid.